Right, good morning and welcome. I'm Mr. Simons. In this lesson, we're looking at Theorem 4 and its converse and its corollaries. Right, so in short, Theorem 4 states that angles in the same segment of a circle are equal. Right, so if we get Theorem 4, given circle with center O and arc AB, so there we have arc AB, center O, subtending angles ADB and angle ACB. That's side 2, you see ADB and ACB required to prove ADB equal ACB. Right? If we go over for construction, we'll always first draw that two radii, AO and OB there, depending on which drawing they give you, radii AO and OB. So according to Theorem 2, angle O1 here, right, is subtended by arc AB, and if you look at there, vertex D goes back to AB, is also subtended by arc AB. So angle at center must equal 2 times angle at circumference because it's subtended by the same arc. Alright, so O1 equal 2ADB, angle at center equal 2 times angle at circumference. But if we look at angle C here, it's formed by this vertex C. AC and CB are also subtended by arc AB, and O1 is also subtended by arc ACB. So therefore that angle and this one, center, circumference, O1 is 2 times the size of angle at circumference. So there O1 equal 2ACB. So if O1 equals that and it equals that, I can simply drop the O1 and now state that 2ADB equal 2ACB, therefore ADB equal ACB. Yeah, same thing but more visible. If you look at O1, subtended by arc AB. If I go backward angle D, DA, and DB also stops by AB. So this angle, 2 times the size of that angle. Same thing with angle C. It's also subtended by BA. So therefore that angle there is half the size of this one here. So if they both equal to the angle at the center, I can state that they are equal. So that's Theorem 4 in short, stating that the angles that are on the same side of the circle, same segment, must be equal if they're subtended by the same arc or chord. Right? Let's look next. So Theorem 4b, if a line joining 2 points subtends equal angles at 2 other points on the same side of the line segment, then these 4 points are concyclic, meaning the 4 points must all lie on the same circle. So we say line segments subtend equal angles on the same side. You'll see later on when you start doing problems, one of the problems is I have to use Theorem 4 to prove something is a cyclic quad. So in exam, given line segment AB, subtending equal angles D and C on the same side of AB. So according to them, this angle is equal that, required to prove that A, B, C and D lie on the circle. So there technically you see C is not on the circle drawn, but yeah, let's solve. So Theorem 4b, short, is the first proof by contradiction. In Latin it's called reductio ad absurdum, meaning to reduce to absurdity. Method as follows. A lot of you will do this method in general when you want to prove. Those of you that like to use your brain, assume the theorem is false, then prove this is not the case. Conclude then the theorem is true. So as proof, suppose that the circle through D, B and A does not pass through C but cuts AC. Right, so it cuts AC there. Then I can say that this angle D must equal that angle E1. Angles in the same segment. You see, if I come back with E1, it rests on AB, and if I come back with angle D, it also rests on AB. So they have a common chord, therefore we can say they are equal. Right? But in our statement, we said that angle T equal angle C. That was given to us. So then from what we've proven, angle E must equal angle C. Right? But this is not true. Because if we look there, I have a triangle ECB. And E1 is the exterior angle of that triangle. So E1 there then technically equals B1 plus C. Right? Exterior angle of a triangle. And hence E1 not being equal to C, our assumption the circle does not pass through C is then false. Therefore A, B, C and D are concyclic and lies on the same circle. So that's the converse of theorem 4b. We still have some corollaries. We're going to look at things that's proven due to the theorems. So, corollaries of theorem 4. Angles subtended by arcs of equal length in a given circle are equal. So you see there that NO and QR are the same length. So if they're the same length, then this angle that's formed, P, which goes back to QR, and that angle M, which goes back to NO, those two angles must be equal. So if NO there equal QR, then angle M equal P, and we say equal sides subtend equal angles, or other people just say equal sides, equal angles, right? Look at the second corollary. Angles subtended by arcs of equal lengths in two different circles with equal radii are equal. So we take point O there and point O there being a center. If AO, right, equal EO there, right, because of their radii, and AC here equal TE, then the angle TE faces that angle F, and the angle that AC faces P there are equal to each other. So P equal to F. So this concept we will still use when we have to prove congruence in a side-side angle. Right? And if you go last one, very common one, tested a lot in exam. Right? If this angle here, equal angles, equal side. If angle A1 equal angle A2. So if A1 equal A2, then BC, that chord BC, must equal the chord CD. Right? And we say chords or arcs of a circle are equal if they subtend equal angles at the circumference of the circle. So if they subtend equal angles at the circumference, very important, not in the middle of the circle, circumference, then line BC must equal line CD. Right? And that's theorem 4. One of the most widely tested theorems. Somehow, some way, it always gets itself into different, bigger problems that we will do later on. Right? If you enjoyed the lesson, please like and share and help as many learners as we can. Subscribe if you want to stay up to date with all the videos being uploaded.